Good morning. We're going to start with P27 today, all about social engineering, and we're going to try and put that in the context of what we mean by cybersecurity. We want to break social engineering down into multiple areas, so phishing, pretexting, baiting, quid pro quo, and then talk about an acceptable use policy. We'll talk about the one we have at school in Fulford, and ways that could be adapted or strengthened or improved in other places. So if you think about hacking in misusing computer software and hardware, then social engineering doesn't actually involve computers, or it doesn't have to involve computers. It's just manipulating people. So it's exploiting human behavior. People, generally speaking, are far too trusting. So how can you protect against social engineering? Well, society breaks down if there's no trust. There needs to be some trust, but it needs to be intelligent trust and selective trust. So it's almost impossible to completely prevent social engineering, but we can avoid it as much as possible by having a list of rules to say what common sense is, as in what you should do, what you must do, what you shouldn't do, what you mustn't do. Put it in a document and make all of your employees or all of your students sign it. So at school, we say that you can only access certain things on the internet and some things are blocked for your safety and for mine. We prevent you from installing stuff, otherwise everyone would install games, and that'd be the same in a business. Some schools prevent you from plugging in USB sticks because that's a big vector for transmission of viruses. We do a lot of training in school, thankfully now, starting this year, on how to recognize phishing emails, so we'll go through what phishing is this lesson. Sometimes we use two-factor authentication, multi-factor authentication, so it's not just a password. We should ensure that all employees are trained so that nobody can phone up and say, oh, could you just reset the password for the admin account? And then somebody unsuspectingly gives that away. And sometimes there's limitations on what you can and can't take away. I'm not allowed to take home the register, for example, on an unencrypted device because it's got sensitive personal information. Got to be really careful in school how we handle this, even more so if it's personal information in a business. So, for example, if somebody downloads an MP3, they might have the rights to that MP3, possibly not, but it's possible that they've downloaded it without permission and it's in breach of copyright law. And if they share that on the shared drive at school, then you could then argue that the school has also broken copyright law and could be fined each time it's listened to or each time it's shared. I just want to focus on the Word document for this. So you're going to need to do a little bit of research. You've got the links here. Phishing with a PH is just like phishing with an F, in that you are reeling people in with bait. You give them some bait, and I've had at least 3 phishing emails this morning saying, congratulations, you've won, or would you like to find out more about this invoice, or you can buy this nice and cheaply. It gives some bait. It's bait I'm not expecting, but it's asking me to click on a link. So you can use the link on your Word document. Pretexting is often when you receive a phone call that gives pretext, that gives some context. Somebody tries to pretend to be someone that they're not in order to give away information that then could potentially be used in a targeted attack against you. So if people are employed in, say, the HR department, it's their job to be helpful. If they get a call from somebody pretending to be the boss of the company, they're going to be nervous and they'll want to please that person. So we need to make sure that people prove their identity. How can you do that? Well, you do that through staff training. You do that through a guidebook. You do that through an acceptable use policy and staffing policy that makes sure that people know how to spot this stuff and aren't afraid and aren't ashamed to get people to prove who they are. So the next one talks about baiting. Baiting's where it says you're using natural curiosity to try and bait people. So you could argue phishing with an F is baiting a fish. Phishing with a PH is giving people bait by an email or something. Baiting is physical, as in you find a little Raspberry Pi, or you find a CD, or you find a USB pen drive, and you rely on people thinking, well, what is that? Let's plug it in and see. And they plug it into the network and it launches its attack. And then the last section is about quid pro quo, which is a Latin phrase that just means you get something if you give something, as in you get something back if you give something away. So people generally are quite cynical now, thankfully. They know that if something looks too good to be true, then it probably is too good to be true, so it's a fake. So if people say you're going to get a brand new iPad for free, they probably won't click on a link. So cyber criminals always try and push things further. So they've realized that actually you'll get more people clicking on the link if they say, fill out this survey for a chance to win an iPad. So they offer something that you could potentially win in return for a small amount of effort. And then what can happen sometimes is that, well, you put the small amount of effort in, and in return you just get infected with malware. So you just got to be careful. It's about common sense. Well, no, we can't rely on common sense. Common sense has to be written down in an acceptable usage policy. It has to be codified in the training policy that you give to your new staff. Inspecting where things come from, looking at links, checking the domain name, doing some research to find out if other people have been scammed by it, not taking things at face value. So I find it quite ironic, actually, that there's a link that you've all just blindly clicked on. It shows that hopefully you trust me and hopefully you trust these resources. But we click on this, we get a 404 link, which means it can't be found. If you just search for sample AUP, acceptable usage policy, then you should be able to find it's the first link. It's the same domain, get safe online, but the URL is slightly different. Why isn't it working? I don't know. It looks like they've just updated their WordPress site, and it uses a different way of finding their resources. But it's basically a list of things saying, if you work for this company, what are you allowed to do? What are you not allowed to do? It is literally an acceptable usage policy. What you are allowed. So policy is a set of rules. Things that are acceptable means things that are allowed, or how you use technology. Put that link on here, but obviously that won't benefit you because you've already got your document. You just need to search for sample AUP. Just to confirm, whilst you're doing the last activity, activity 2, your job is just to explain why these steps might be necessary. So this just gives the example of Acme Corporation. Say if you were working for Amazon, then it would say Amazon instead. You need to explain why it would be a bad thing if this happened. What could go wrong? Why they would want to prevent employees from doing that. When you've finished your P27, we want to make sure that it is uploaded, please, onto half term 5 issues and impact 1, please. So we didn't get a chance just before half term and before the mocks to be able to do P23, and I know it came up in the assessment and we said that we'd do it and I completely forgot about it, so we're going to race through it now. Remember, the purpose of an operating system is to manage system resources, so it needs to provide an interface for the user to be able to access files and folders. It needs to be able to manage those files and folders, manage the processor time, manage the memory, but there are some things that the user needs to be able to do to be able to take control of system resources as well, and we call those utility software. So it could be things like backup and recovery, recovering corrupt files, compressing files to take up less space, or disk defragmentation. So we need to be able to visualize what those look like, what they're used for. Sadly, you're not going to have access to those kind of resources on the school network because they'll all be blocked because of the acceptable usage policy we've just been talking about. But you can try them out on a virtualized computer. So you've got P23 from half term 4. We're going to try out an old-fashioned Windows 95, and it should boot in less than a second. And this is just running in JavaScript. It's a simulated version of a computer. So it's not a real computer, it's just running in the browser. I'm going to go Programs, Accessories, and System Tools. And we can see a lot of those things that we talked about, the utility software. So let's start first of all with Scan Disk. This is like scanning for corrupt files. So if this was a real computer, it would physically spin up the hard disk and it would check through all of the different sectors on that magnetic hard disk to try and find bad sectors, ones that it couldn't read from or couldn't write to. And it would tell you which ones can't be used anymore, and then it would mark them so that they wouldn't be used, so that your data wouldn't be corrupted. But obviously, because this is simulated, it hasn't found any faults with them. Alternatively, you could use a disk defragmentation thing or disk compression, and you can experiment with these. Compression means that if there's like loads of documents that you use that you used to use like years ago that's taken up loads of space, you can squash them. It would take more time to be able to decompress them before you can access them again, but it would save space. So great in the days when people didn't have very large hard disks. The one that people understand the least in the exam is a defragmenter. So this is only useful for a hard disk drive. It's utterly pointless for a solid state drive, and we'll talk about why in a moment. So it can take hours to do this. Again, this is a simulated hard disk, so it's not very fragmented, but I'm going to start anyway. And I'm going to show details. So this used to run for hours on end. I remember setting this off for hours in the hope that a defragmented hard disk would run a little bit faster. What you're seeing is all of the sectors, all of the physical spaces on a hard disk that are taken up by different files. Some of them are system files and can't be moved. Other ones might be part of your game, might be part of a Microsoft Office file. If they are contiguous, as in if they're sat next to each other, if they're organized close to each other, then it's going to be faster loading that data. Remember, a hard disk drive works by, let's just see if we can make a quick example. Is it going to work? A hard disk drive works because you have a spinning platter. Let's quickly make a spinning platter. Shift A, add a cylinder, squish it down. There it is. And it spins around and around and around like this. Can you see that that's supposed to be spinning? And if there is, how do I draw on it? Something stored here, but the bit that reads is currently looking at this part, then you've got to wait for it to spin all the way around before the sensor can detect it. So that's why hard disk drives are so slow, because you've got to wait for it to spin round. But remember, it might not just be one physical sector on the hard disk drive that you're reading from. There might be a bit of the file over here, a bit of the file over here, a bit of the file over there. So you've got to wait for them all to spin round, and you've got to wait for the sensor to kind of move to the right place in this axis too, which is a problem, and it takes ages. If, however, you defragment your hard disk drive, it means that all of the bits that you need for a file are next to each other so that you can read them all very quickly. So why is it unnecessary to do that for a solid state drive? Well, because there's no moving parts on a solid state drive. It makes absolutely no difference if your data is fragmented, because it takes the same amount of time to read it in solid state, regardless of where it is, which is completely different to a hard disk drive where it takes a lot longer for it to move to the physical right position. Okay, so your job is to go through and explain what these are. So corrupt files, how does it work? Well, it tries to guess to try and make it work again. Backup and recovery, I think you can blag that. Data compression to save space, we've just shown that one. This is adding a password to sensitive stuff, and this is like an antivirus thing. So it's not too complicated, but you can experiment with it by clicking on this link, try out different operating systems, and then the Windows 95 one. Have a play, see what you can do. So when you've finished your P23 on utility software, please make sure it's uploaded to half term 4. I've just confirmed to the class this week that because we're doing 2 in 1 lesson, if you prefer to finish off this P23 for your homework, that's fine, instead of this week's half term 5.3, I think it is, which would be CT27 or P27. You're welcome to finish off today's lesson work instead, but make sure they are both uploaded to the VLE and uploaded to class charts as well. Class charts so I know you've done it, VLE so that I can mark it.